Volume. We need focus. You don't be writing other things. Lena ahead in the game. You need to focus on what went wrong on the quiz. This was, I thought, a very hard quiz. God bless. And the thing that was completely unfair about the quiz was question number 3. But like I said to you before, the problem with it is, if I didn't give it to you today, then you would have had to take the third quiz on a Monday, and most kids do not do well on Monday. So I would rather have gotten beat up a little today, knowing that by Friday we'll be done with the series of quizzes and we won't have a problem. So, without any further ado, let's take a look at the quiz now. All right, now the first thing is, guys, please. The first thing I want to ask is this. Did anybody here get concerned or panic when they saw all the fractions in the first question? Okay, it should never happen. Now, if you didn't have a calculator, I can understand. But you have a calculator, and your graphing calculator does absolutely, positively everything that's fraction related on, it does everything that's fraction related on the test. So, this question is really, for all intents and purposes, because the calculator will do all of the fractional stuff. Come on, don't play games here. Because the calculator will do all of the fractions for you. Then, oh, it's blinking. Is this really using up so much battery? Oh man, this is like unbelievable. Wasting time here. Okay, because there is a calculator to do all of the fraction work for you, and you don't have to do any of the fraction work, there should be no sense of concern on your part. There should be no sense of panic. All right? So I think it's really, really, really important that you don't get negative thoughts to rush into your head right away when you take a look at number 1, just because it has a whole bunch of fractions in it. So what I'm really getting at is, if I would have given you a question that looked like this. Ready? What if the question instead would have said 3 times x plus 4 plus x equals 3 minus 2x. Would you have been in such a state of panic?
No.
That's the same question with no denominators.
Yeah.
Same exact numbers, no denominators. So if you knew what to do here, which was namely distribute, combine like terms, which would give you 4x plus 12 over here, equals 3 minus 2x over here. I have 4x because 3 times x is 3x, add the x, 4x. And I know I'm going quickly here, and then you would add the 2x to both sides. If you have a sense of direction with this, if you would have looked at this one and said, oh, I know how to do this. I mean, I might not be able to do it in my head, but I know what steps to do. If you could do that, then likewise, you can do this. All I did was distribute to 3/5. 3/5 times x is 3/5 x. 3/5 times 4 is 12 over 5. Now, if you can't do that in your head, that's not a problem. You take your calculator. You do parenthesis 3 divided by 5, parenthesis times 4. It'll tell you, bless you, it'll tell you 2.4. But then you need to remember to hit math, enter, enter. How do you convert decimals to fractions on your calculator? You hit what? Math, enter, enter. Let's do that all together so I'm sure you know how to do this. Ready?
Where is it?
Do parenthesis 3 divided by 5, parenthesis. Then do, because we're distributing now, then do times 4. I don't want this. Come on, get rid of this. Oh, man. I don't know why it's doing this, but we're gonna have to
I
work
got
with
it.
Okay, when you do that, it'll tell you 2.4. And then if you hit math, enter, enter. It'll tell you 12 over 5.
Whoa.
Okay?
That's the way I learned.
So that's how you can generate all of these. Now, x over 2, you should know that's 1x over 2. And then it's equals 3 minus 2/3 x. So all I did was distribute on the first step. The next step, I want to combine my 3/5 x and my x over 2. So that's really a matter of adding 3/5 plus a half. So let's do that together, ready? Everybody, parenthesis 3 divided by 5 parenthesis, plus parenthesis 1 divided by 2 parenthesis. In other words, you're gonna input 3/5 plus 1/2. When you input 3/5 plus 1/2, it'll probably tell you 1.1. But we want to work this in terms of fractions. Math, enter, enter. Again, what do you press when you want to convert a decimal to a fraction?
Math, enter.
Math, enter, enter. So that gives me 11x over 10 plus 12/5 equals 3 minus 2/3 x. So now, look, you know how to do this. Add 2/3 x to both sides. So then I just use my calculator. I type parenthesis 11 divided by 10 parenthesis plus parenthesis 2 divided by 3 parenthesis. And when I do that, I'm pretty sure I come up with 53 over 30x. Could somebody do that quickly just to verify? I did it in my head. All right. Remember when you get your decimal, you do math, enter, enter. And I sure hope
3
this
over
is.
30.
What's that?
Wait, I inputted the fraction, I got
Right.
the decimal, and then I did math, enter, enter. It
And
said
did you get-
53 over 30.
Good, that's what I want, 53 over 30. That means I did it right. Yes?
Did you combine 3/5?
Yes, I combined the 3/5 and the 1/2 s. Okay?
Oh, yeah, because there's a 1 in there.
Right, now, the next thing is I need to subtract 12 over 5. So I just do it on my paper, minus 12 over 5, minus 12 over 5, and then you just type in the number 3, minus, parenthesis 12 divided by 5, parenthesis. And it'll tell you 0.4. And then you, right, 0.4 or 0.6? 0.6. And then you go to math, enter, enter, and it'll tell you that that is 3/5. So now I have 53 over 30x equals 3/5. Now, here's where, in the years past, we would have just taken and multiplied by the reciprocal, and I started to do that. I would have done 30 over 53, so I could do die and over here. But on your calculator, it's actually easier than that. On your calculator, you do parenthesis 3 divided by 5 parenthesis, divided by parenthesis 53 divided by 30 parenthesis. And when you do that, you come up with 18/53.
I was close.
Okay? So the point behind this, there's 2 points to the first question. First off, let me ask you before I tell you the 2 points, was it really that hard?
Yes, so
No,
hard.
no. The fractions were hard. Can we agree with that?
Yeah, that's
But how
hard.
to do the question. Did you know, once we started, if there were no fractions and it was just whole numbers, would it have been easy? Yes. So what you need to understand is not how to do the equation, it's how to do the fractions. And the way we do that is parenthesis, numerator divided by denominator, parenthesis, get the answer, math, enter, enter. But the steps are the same. Yes?
How did you do the x divide, like, over 2?
Oh, well, you need to know what that is. What number is always in front of the x that we don't bother to write? 1. So now, just as this was 3 over 5, or 3/5, this becomes 1/2, and I just operate with a half.
Oh.
Okay? Yeah, so in my opinion, this question, once you realize the power of the calculator to help you, is very easy. Now, on the Regents exam, they usually put a linear equation, but they almost always make it exactly like this. In fact, I believe this question came off a Regents exam. All right, they'll make it a 2-point question, and again, if you didn't have a calculator, it would be hard, but with a calculator, it's not difficult at all. All right, so, next up, the middle question. I am so thankful that I get to grade your papers, because apparently I have been having a really good conversation with the wall the last few days. What's that?
I think I did some of these too.
Well, here's the deal. Listen, you need to stop talking and you need to really pay attention to this, because the last couple of days, I tried very hard to make this point to you, and apparently it fell on deaf ears. I feel like I'm talking to the wall. My mother used to say that all the time. She'd tell us to do something, we wouldn't do it. It was like we ignored her, and she'd go, "Am I talking to the wall? Hello, wall!" That's exactly how I feel at this particular point in time. Because I remember when we introduced how to do the subtraction with the whole parenthesis, because you're subtracting the whole thing, so it needs to be grouped together in a parenthesis. Right? Anthony, pay attention here. Everybody look here. Very, very, very important. I want to make this point. I never want to need to make this point again this year, because it'll save you pain. Not me, you. Listen. The minus and the parenthesis, because I'm going to subtract the whole thing. I said to you specifically that I've been grading papers for 32 years. Do you remember this? And in 32 years, I have found that students who do it this way get it right, and students who do it any other way. I think one kid, either in this class or the last class, might have been Spencer, somebody said, "But I do it in my head." Another kid said, I just subtract. And I saw on some of your papers you wrote it vertically, one on top of the other. They just get it wrong. I don't know why they get it wrong. I just know in 32 years of grading, when you do it that way, you'll get it right maybe 20% of the time. And when you do it this way, you'll get it right 95% of the time. So for your sake, it just works. So go with this. Ready? 3n squared minus 5n plus 8, that doesn't change. Here's the -1. You remember yesterday, we said we're distributing the negative because there's really a 1 in front of the package. We did it 2 days in a row. Distribute it. I said the thing kids always forget is to change the first one. N squared positive becomes negative. Plus 4n becomes negative. Positive 4 becomes negative. Now just combine like terms. 3n squared and a negative n squared is 2n squared. Negative 5n's and negative 4n's is negative 9n's. Positive 8 and negative 4 is 4. Easy as can be. But every paper I graded where they didn't do it that way was wrong. Every single one of them in the wrong. So make sure you put the 1 in front, distribute, show the step where you change the signs. Remember I said yesterday that the minute you would show this step on a Regents exam on a part 2, 3, 4 question, you're going to get half credit. Okay? And you do that, you'll get the question right almost always, except for the odd careless mistake. Okay? And now, the third one. Using an area diagram to find the product of this and this. The one thing I didn't get through yesterday, and I did say number 3 was unfair today. The one thing I didn't get through yesterday, remember we did Russian multiplication? Okay. There's also this thing called the box method. Now, the box method, God bless you. Let's say I wanted to do x plus 3 times x plus 7.
Physics logic taught us that method.
That's right. Now, here is the box method. A little sloppy box there, but x plus 3. Guys, please, I'm in a bit of a rush here, okay? X plus 3 times x plus 7. The box method is exactly the same as Russian multiplication, with the difference that I don't need to draw the diagonals in the middle of every box. X times x is x squared. 3 times x is positive 3x. The one thing that I see kids who get it wrong is they don't put the signs in, so make sure you put a positive 3x. X times 7 is a positive 7x. And 3 times 7 is a positive 21. And then, just like with Russian multiplication, you're going to add on the diagonal, okay? This is going to be plus 21, this is going to be plus 10x, and this is going to be x squared. So the final answer is x squared plus 10x plus 21. I don't really care if you can do that right now. You don't have to copy it down. It's not a big deal. The reason it works for an area diagram, if I wanted to do an area diagram for 3 times 2, here's a rectangle, here's 3 in one direction, there's 2 in the other. What's that area? Count the boxes. 6. So this is an area diagram. It's also a box. This is an area diagram for 5x squared plus 9x minus 3 and 3x minus 7. So I put down 5x squared plus 9x minus 3 across the top, and then I put 3x minus 7 across the bottom, and I just fill in every box. It doesn't even matter what order you go in. Check it out. Ready? Try to listen more than you write. Negative 7 times negative 3 is positive 21. Negative 3 times positive 3 is negative 9x. Positive 9x times 3x is 27x squared. 9x times negative 7 is negative 63x. 5x squared times 3x is 15x cubed. And 5x squared times negative 7 is negative 35x squared. And I should not have really, I tried to show that you add on the diagonal. Plus 21, bless you. Negative 9 and negative 63 is negative 72x. God bless. 27 and negative 35 is negative 8x squared and 15x cubed. Yes?
So like, if you didn't add it, would it be okay? Like if you
You have to combine the terms. All right? Any other questions? Now, this is, the last 2 days I forgot to update the website, but I have the videos done. They'll be uploaded probably next period. And I will upload this video as well. So if you still have any questions about the quiz, which is legitimate, I would suggest that you watch the beginning of the video, what we just covered now, to remind yourself of the quiz as we work through, because you know that tomorrow you're gonna get the same kind of questions, okay? The big thing on the second one is write it out the way we showed you. Kids tend to get that right that way. And if they don't, they tend to get it wrong. Okay. Next up, last night's homework. I just want to show you some of the answers. Okay? So take a look. You'll see a little bit of that fraction work, which I think you should now understand better. We've got about 2 minutes to go over this, so just take a look. Are there any questions on those equations?
No.
Right? The fraction one may have given you a little difficulty, but now that you know what we worked on, I think you should be pretty good about that. Okay. Next up, the properties. This is the associative property of addition, because what's in the parentheses is changing, who the B associates with is changing. Is subtraction commutative? No. 5 minus 2 does not equal 2 minus 5. If I change the order, it's not equal. God bless. And last, is the set of integers under addition closed? Why or why not? Yes. Because if you start with any two integers and you add them, your answer will always be an integer. You don't add a whole number and a whole number and get a fraction. Okay? All right. Yes?
For the fraction ones on the top, in my upper school, they taught us to get rid of the fractions, you can, like, put them in, like, for letters.
Put them into decimals?
Huh?
You mean convert them to decimals?
No, to convert them to whole numbers. Like, let's say.
Oh, you can distribute across the bottom. We will do that a little bit later in the year.
Okay.
Find the common denominator, distribute it 12 times. Yeah, that's coming. We're not there yet, but it's definitely coming. Okay. Yeah, the thing, that technique is a pretty slick technique, but I don't like to do that one right away because some kids have a hard time finding common denominators. And if you pick the wrong number, it doesn't work.
Yeah, like, on the quiz, I was trying to do that, and then.
Yeah, exactly. But the calculator, I call it the blood and guts technique. It's long and it's tedious, but it always works. So worst comes to worst, you'll get that right that way. All right. Now, today's lesson number is what, 9? No, I mean 29?
Yeah.
29, yeah. You guys and the Math 8 class are midway split in what you are doing.
Do we do any of the same stuff as them?
No. No, you do nothing like them.
No one checked the homework.
We just went over that before. Who said that? Yeah, you're a step behind, Sari. It was, I said you're going to have to do it tomorrow. All right, so today is the same thing as yesterday. Now that we went over how to deal with fractions, what would be a good first step to do in this problem? We're not going to actually do it. Just tell me what the step you would make is. AJ? We're not going to go with that way yet. We're not ready for that. What would be the first step that you should do? Anthony, what would you do, buddy?
You subtract one of the x's.
Yeah, specifically I would go with the 1/4 x. And then I would add the 2/3 to the opposite side and divide. Okay, good. Now that we've talked about how to properly do number 3, can you do it? My guess is on your do it, you didn't do well with it. So everybody on your do it, if you think you got it right, leave it. If not, redo number 3, and we're practicing number 3 on tomorrow's quiz. Okay? So do that. I'll give you a minute or so, minute and a half, and then I'll put the answer to the board up there. So there's nothing new today. It's just the same stuff as yesterday. Okay, check and see if you have the same numbers in the boxes that I do.
I don't even know how do you get that?
You multiply. This and this line up here, so 2x squared times x is 2x cubed. This and this line up here, so negative 5x times x goes in this box, because this is where they line up, negative 5x squared. Positive 3 times x is 3x. Okay? Yes?
You add on the diagonal.
Yes.
Okay.
And by adding on the diagonal, what you're really doing is putting like terms together. Okay? So it's minus 12. Then I have 3x's and 20x's, which is plus 23x's. Then I have minus 13x squareds. And then I have 2x cubes. Okay? Just for my edification, how many people got that right? So we're looking at about 2/3 of the class, maybe even 3/4. So that's way up from the quiz. Kaylee?
Does it matter which equation you put on the top and the side?
If you did it reversed, then this side would have 2 and this one would have 3, and it wouldn't make any difference. Okay? Yes?
How do you get the bottom row numbers?
Add them diagonally. Negative 12, 3x and 20x is 23x. Negative 8 and negative 5 is negative 13x squareds, and 2x cubes.
No, but how do you even get the values for the bottom row?
This guy, look. This goes down here, this goes across here, this times this goes in that box. This goes down here, this goes across here, this times this goes in that box. Yes?
So when you multiply an x squared by a regular number, then it's just cubed, because,
Well, because there's an x here, there's really a 1, and you add exponents, 2 and 1 here. Okay? All right.
When you do that, like, say like the x, like that x over there was 2, then would it be 4?
Yes, exactly. All right? Okay, so, next up, we also need to be able to do double distribute without the box method. That area diagram box method, same thing. But I also want to make sure that you can double distribute without the box. In time, nobody uses the box. Once in a while, they'll ask on the Regents use an area diagram for a 3x2. But this we should be able to do in our head. Let's see you do the bottom one. Double distribute. Bless you.
Wait, which one we can do?
This one here, Anthony. What do you think? Getting the same answer? Right, are we good?
No,
No, what'd you get?
not that.
Did you do double distribute? Cover the negative 1, 4n times 3n is 12n squared. 4n times negative 7 is negative 28n. Now cover up the 4n, distribute the negative 1. Remember the negative changes signs. Negative 3n, positive 7. These guys here in the middle will always be combinable.
How'd you get 12 into the second power?
Because 4 times 3 is 12, n to the 1 times n to the 1 is n to the 2. Okay, very quickly. How would you do, I don't think we have time to actually do it, but how would you do the next one, which is a triple distribute? Folks, how would you do the next one? Janelle?
You first have to x squared to.
Okay, so Janelle has the first step, distribute the x squared. What's the second step? Somebody else help me, second step, Brian.
Distribute the negative 5x.
Good, distribute the negative 5x. What's the last step? Distribute the 2, then combine like terms. Okay? All right, very good, folks. Study up on that quiz so that you're 100% ready for tomorrow. Okay?
Is he like more